Salutations and welcome to Space Time Continues. My name is Mary Louise Davey. So, I'm an author, we all know that, yes? Okay, I'm a sci-fi author. And in my last book, Target Earth, You Only See What You Want To, my main character, Danny, for Danielle, is explaining to her buddy, well, to the alien Ishmael, about the space elevator and the space train that exists then, and then it leads to the lunar space elevator. And she's explaining that sometimes Earth does stuff not because it needs to, but because it can. So, space elevator, is it something we need to do? Well, is it something we can do? Not just yet, but just about. But is it worth all that money? Possibly. There's a lot of savings we can make getting to space without it. You know, getting to space without using a launch equipment, without spending millions of dollars on launch to get a satellite, take it up in the space elevator, just kick it out the right orbit. I mean, there's a lot of benefits. But do we absolutely need it here on Earth? And then we're going to look at lunar elevators and how that would be very necessary and very easy and would take only what we have now. And we're going to look at maybe a skyhook or escalator type on Mars and how that would be super important and super easy. So yes to everywhere else. It's just, does it make sense on this planet? And actually, can we? Well, you know who I think's a really smart person? Elon Musk. So why don't we hear what he has to say?
I mean, I think it would be awesome if there was a space elevator. I wouldn't hold my breath. I mean, I don't think it's realistic, but, you know, I'd love to be proven wrong. So
a space elevator. What is a space elevator? Well, it's a lot like one of those maglev trains. A cable tether reaches up from the ground to a counterweight 100,000 kilometers up in space. Elevator cars or climbers are provided electricity beamed at it from below and maybe solar power from above. The idea was first come up with in 1895 by Konstantin Tsiolkovsky. His structure would be under compression, supporting its own weight. It was not quite what the one is today. Since 1959, we have more or less focused on the tension, how it would be held with a counterweight up in upper space, maybe an asteroid, maybe a spaceport, all these sorts of things. Perhaps the best example of sci-fi authors using it is Arthur C. Clarke. In Fountains of Paradise. In the 22nd century, Dr. Morgan is this famous structural engineer who hopes to develop the space elevator. He wants to bring it to reality. But the only suitable point for having it, starting point for the Earth station or anchor or whatever you want to call it, would be on this mountain where Buddhist monks live. And, well, a whole bunch of stuff happens, and you have to read it to know, but what does it take to build a space elevator? Well, the cable from the Earth up is going to be a problem because of a whole bunch of details that I'm going to explain as this goes on regarding tensile strength. Carbon nanotubes, a material that we just are learning how to manufacture and to make, and we can only do in the lab up to half a kilometer, at least that was the number in 2013. So we'll see. But hasn't been done as yet. Maybe soon, though. But the best part and the coolest part is that this is something that is applicable to other planets, like the Moon or Mars, places where they don't have the atmosphere, the gravity that we have, the problems that we have. They can do it with materials we have now. So let's go into a little depth on each of the pieces needed. First, you got the anchor. It's typically a mobile station, a large ocean-going vessel, or maybe an oil platform. It has advantages that it can move. Maybe you have avoidance systems in it, so it can move out of the way of a hurricane or tornado, although there aren't many along the equator where it would be located. So, depends. Or up, if you had one up on a mountain, this is the other area of thought is if you had it on a mountain, yeah, you'd be closer, there'd be less tension on the cable, but you can't, and yeah, you could see down and shoot off terrorists, perhaps. But it seemed, I particularly like the located at sea thought. That one means more. But security is easier from a floating base. The underwater technology, the laser beams you could send down through like a great no-fly zone, military presence, constantly circling boats or something like that. And with the avoidance system, you could rough seas, bad weather, or incoming meteor, not a problem. So then the tether. That's the next part. Well, the tether is, as I've said, the piece of wire or cable that extends up 100,000 miles. It's 35,786 kilometers. So it would have to be a really strong one. And the reason why is, okay, think of it. Material, okay, forget all other forces operating on this cable. The cable is coming down. Now the cable has the force of gravity of whatever weight exists beneath it. So this is going to take into account a taper ratio. So you're going to have to consider that whatever it is, it's going to have to grow. It's going to have to be wider and wider to support all the weight that's beneath it. If it's steel, say, because that's a really strong material, right? Okay, so we're using steel. Now, steel, it's pretty strong, but it requires that you go out like this. You're going to have to taper out. It's got a large ratio. So what is it you're going to need? And I'm sorry, taper ratio is steel, 1.6 times 10 to the 33. So that means it's going to be really, really wide. Like the observable universe is going to be the entire width of the top. Actually, it's 11,000 times the observable universe. So we can't really accomplish that, can we? Okay, so then let's try Kevlar. Kevlar is a really strong material. And let's see, I worked out the math, and it's 2.5 times 10 to the 8th for its taper ratio. So that means it'd be about 10,000 kilometers in diameter. So that's better. We're going the right direction, but we still don't have it. So let's try carbon nanotubes. Well, that would be, okay, think about it, 1 centimeter at the bottom. But at the top, with the taper ratio of between 2 and 20, it would be about 2 centimeters. So carbon nanotubes, at least at the moment, based on what we currently know, is the item to go with, except for it's not as easy to form the material and weave it, basically, to such great lengths as one would hope. So hopefully we'll figure this out. But all right, if we had that, that's the item we would want to go with. So onwards and upwards. Actually, yeah, upwards on the space elevator, huh? Okay, so if we got all this going and we have all the cable, we don't have the cable, but we sort of do. Let's think about the climber. Well, there's going to be several climbers. First off, you're going to have to make them light, and you're going to have to make them weather resistant. And I don't know, you don't want to add too much weight to them because you want to keep lifting that enormous cargo you'd be taking up. That'd be saving so much money being able to lift it up. You could take the cargo up on a climber that maybe has no atmosphere and no oxygen. Or it may be one that needs atmosphere. So then you have another climber car that has atmosphere but no oxygen. But then you have another climber car that is for the astronauts to take them up to their spacecraft. So that's probably, they're standing there or they're sitting there on a bench and they just plug their oxygen into a special output, and now they're perfectly fine traveling there 5 days to get up into space. Or you have another climber, and this climber has a TV, a window or a virtual window, a couch, and a bar. and maybe you've got some casual space tourists hanging out and looking out, enjoying the view as they go through all the orbits and then get up to the Clarke orbit and then turn around and go back down. So that's the climber. And then you get up, and what's on the other end? The counterweight. So on the counterweight, what are you going to do on the counterweight? Well, the counterweight, as I said, probably an asteroid while you're building it, because you need something to just to hold it up while you go up and down with climbers. They have a specialty kind of climber that to help you build out the carbon nanotubes. So it has to it basically manufactures it on the cable. Just keeps going up and down until it's the proper diameter, proper thickness, and it can hold the proper weight. So that's more like a maintenance cable. So you got that. So you're up at the spaceport. Maybe you can house all these items up there as well. The space janitor type climber and the other climbers. Maybe you put them on, or maybe they're down at the ground level. Then you've got several parking spaces for your spacecraft, because once you had the asteroid for most of it, but then you put the asteroid away and started building something really cool, because here on Earth, we like to build stuff, not because we have to, but because we can. So that's the space elevator on Earth. So the fact that we can't really build it now, but we will be able to in the foreseeable future. But does that mean we should build it? What's your thought? I'm thinking not really. But if I go into the lunar elevator, well, that makes a lot more sense. See, there's all these countries and commercial companies, some for mining, maybe some science labs, some computer companies want to keep some servers up there. So there's all these companies and people that want to go up there. But that means there's going to be a lot of supplies they're going to have to get there. So how about you go up into cislunar space down to the moon? Well, it's a real simple thing. And what I'm going to show you is a quick video from Liftport. Okay, so first they're sending the equipment out into space and to cislunar space, because once it arrives in cislunar space, that they can connect to. So they're easing out into it, crossing into space. This is really cool because it all comes out of one object. Kick that off, expose the ribbon. Now the ribbon gets dragged on down so that the ribbon goes to the lunar surface. Now keep in mind, this ribbon's probably Kevlar. It's not the carbon nanotubes or such that we still don't have the ability to weave enough kilometers, miles, so that we can connect that on the Earth. But we can do a Kevlar ribbon for the moon. So it carries down the Kevlar from cislunar down to the surface. And then this is my favorite part. It basically drills itself into the lunar surface so that it's held secure. And theoretically, from this point on, you could just shoot over some cargo from cislunar space down to the surface by attaching it to the ribbon. Now, instead, here's your cislunar space. Maybe these are labs or locations where you just pull it all together to send it down. But now we have climbers. The particular climber being used might not be the one that would be used for a different set of supplies. So it can be moved about, say, have oxygen, have atmosphere if needed, or just throw the boxes in there and let's bring them to the surface. It can handle it any which way necessary. So there's the overview, and you see the climber coming towards you, or towards the lunar surface as it would be. And there you are. So as you can see, setting up and using a lunar elevator is relatively easy. Now, granted, the items that do all that neat process and, you know, zoom out and send out the ribbon and do all that, well, they have to be made. But Liftport did a concept test way back in 2005 using a really large balloon up about a mile. And they tested the ribbon. Prior to that, they did a test that involved the climber. So the plan for the lunar lift revolves around a space station. Now, obviously, it starts up here and it goes down, so there's got to be something up here with cislunar space. Well, it's the Pico Gravity Lab. And the Pico Gravity Lab is going to be built by Orbital ATK. So it will be positioned at the lunar Lagrange point, spot that's between the gravitational poles of the Earth and the Moon. So they go like this, and it makes like a gravity well. So the Kevlar ribbon will be attached to the lunar surface through the use of a docking port. And then it'll be up at the Pico Gravity Lab. So the Pico Gravity Lab, because of the gravity well, will hold the ribbon taut. So then you just shoot down the supplies. So now you can use, you saw in the video, an electric powered climber. You could do that. There are other ways you could do it, as well as using another wire off another direction. So it pretty much just uses momentum. But these are, you know, picayune things. You can go this way, you can go that way. But basically, you can do it real easily. So pictured is one of the concept vehicles that Liftport designed, Concept Rovers, basically. And they picture the use of this being for something like helping to build the Liftport when it's the part that goes down to the Moon, helping in the maintenance, and perhaps playing poker. Okay, no. Perhaps helping to mine or do something like that later on. Now, one method that I had worked out for Mars was sort of a space loop / escalator. It was my book Mars Impending, and what I had was 14 robotic orbiters / vehicles that would form up in Mars space, enter the atmosphere, and they would shoot around, and they would actually build from them the space loop. And what I had in the book is had a problem occur, because they were supposed to be built just around Phobos, but Phobos had an interior that was all ice, and so it fell out, so they couldn't make it the way they meant to, so they ended up using Phobos and Deimos. Now, Phobos is approximately 22 kilometers or 14 miles across. Deimos, 13 kilometers or about 8 miles across. Phobos orbits 600 kilometers away, or 3,700 miles, and it orbits Mars 3 times a day. Now, Deimos orbits farther away at 20,000 kilometers or thereabouts, and that's about 12,000 miles. And it takes close to 30 hours to travel around Mars. Now, 30 hours, to let you know what that is, a day is, okay, what's a day here? 24 hours? Well, a day on Mars, a Sol, is 24 hours, 39 minutes. So really not that dissimilar. It's dissimilar. So if you're wondering, you'll be just as, you can keep the same schedule you have here on Earth when you go over to Mars to visit. But obviously, Mars is going to become a primary location once we have gotten there, explored there. It's going to be a staging location, if you will. We'll go on to Mars and we'll leave a bunch of stuff there because we're going on to the next thing, maybe Titan. But Mars will be closer than Earth, certainly. So we can do a lot of things from Mars, and then maybe from Titan, and then maybe from Europa. We'll be going out and out and out into the universe. So it will be pretty important. Phobos would be used as a source of raw materials for space-based activity, and as an anchor for a tether of carbon nanotube space elevators. One day, a space elevator terminate at the upper edge, and then they'd have another terminate up this way, so that you could, and you would get onto it, okay, from the mountains, or a thing built up, and it would kind of go up like a rocket ship. Kind of be a vehicle rocket ship, would catch into the space loop here, which would loop it up, catch into the other loop, and send it out into space. So pretty cool, don't you think? Send it home on Earth, and now you're also gaining from it, because now you're gaining momentum. You're going to be sent back to Earth, flying. It's going to fling you into space. So you're going to be zooming out towards Earth, and you haven't spent any energy. You've had energy come from where you were thrown. So yeah, you're going to be transferring people, transferring supplies, all to the Martian surface to support the space industry, to support the colonists, to construct space habitats, supply propellant, material of space industry in the Earth-Moon system, as well as around Mars. So there's one kind of, that's really quite interesting. It just zooms around. It's a space, it goes around head over head over head, and what it does is it just takes a spaceship and wings it out from various points. So yeah, there are tons of these. Can be used. Space elevator Earth, no. Space elevator on the moon, definitely. Space elevator on Mars, we could have so many different kinds there. And you could even set up the more simple kind at first to use while we're getting settled in. And then as you've been there a while, as we do on Earth, like to make things bigger and better and faster and cooler, you can make all different kinds of elevators and not have messed up having the elevator you had before. So there's really a lot of cool things about space elevators. There's a lot of cool things about space. Earth makes everything else difficult. I'm not sure I said that right, but Earth, with its gravity, with its different way of being, where we have to fight and spend so much effort and money to get up into space. On other planets, it is simpler, and we can set up a simpler system for both supplies to get down and for us to get up, and for the spacecraft to be launched using that same equipment. So personally, I'm extremely excited, but unfortunately I'm going to have to wait a few years until we get there and we actually utilize something like the Liftport elevator. But I can't wait, because it's going to be in our lifetimes. Is that cool? So anyway, why don't you join me next time when Space Time continues. In the meantime, I'm going to go march for science. You go march for science too.